Welcome to the lesson on reducing fractions to lowest terms. The idea of finding the simplest forms of fractions is a concept that will be repeated throughout many of your mathematics classes. Why should you care if fractions are reduced to their lowest terms? Well, first, it makes fractions easier to compare to other fractions. And second, reduced fractions are easier to work with than fractions that are not reduced. For example, I am sure you would agree that 1/2 is much easier to think about than 25/50. Yet both these fractions are equal. How does one get from 25/50 to 1/2? That is what this lesson is all about. In this lesson, we are going to look at simplifying fractions using two methods that are related to each other: common factors and greatest common factor. Do you remember the mini lesson on finding the greatest common factor? If you don't, it might be a good idea to go back and review that before attacking this lesson. Now, the easiest way to reduce fractions to its simplest form is to find common factors. Before we do this, let's quickly review the concept of factoring any number to the product of its primes using a factor tree. Suppose you are asked to factor 8. 8 is equal to 2 times 4. Since 2 is prime, we circle it. 4 can be factored into 2 times 2. Again, both 2's are circled because they are prime. So 8 is equal to 2 times 2 times 2. If you need further review, please go back to the lesson on prime factorization. So let's use this skill to reduce 6/8, or 6/8 using common factors. The first step is to factor each number into the product of its primes. 6 is equal to 2 times 3, while 8, as we just saw, is equal to 2 times 2 times 2. Next, we circle matches from the numerator and the denominator. In this case, there is a 2 on top that matches a 2 on the bottom. 2/2 reduces to 1. Since any number over itself is equal to 1, we still see that 2/2 is in fact 1. There are no other numbers in the numerator that are also in the denominator. Therefore, the only job left is to put the fraction back together by multiplying the factors. On the top, the numerator, we have 1 times 3, or 3. On the bottom, the denominator, we have 1 times 2 times 2, or 4. Therefore, 6/8 reduces to 3/4. 6/8 is equal to 3/4. How about 15/25? 15 is equal to 3 times 5. 25 is equal to 5 times 5. There are matching 5's in the numerator and the denominator. Again, any number over itself is equal to 1. The numerator is now 3 times 1, or 3. The denominator is 5 times 1, or 5. 15/25 reduces to 3/5. 15/25 is equal to 3/5. For this example, we are going to try one that has many more factors than the examples we saw before. 24 is equal to 4 times 6, or 2 times 2 times 2 times 3. 40 is equal to 4 times 10, or 2 times 2 times 2 times 5. Do you see the matching pairs numerator to denominator? All we have left are 3 and 5. 24/40 is equal to 3/5. As you can imagine, this can get rather tedious. So what other way can we reduce 24/40 without factoring both the numerator and the denominator into a product of primes? How about thinking about the greatest factor they have in common? the greatest common factor. Let's go back to the same example, 24 over 40. This time, however, ask yourself, what is the biggest number that divides evenly into 24 that also divides into 40? That biggest number is called the greatest common factor. Since 8 divides into 24 and 8 goes into 40, 8 is that greatest common factor. 24 divided by 8 is 3. 40 divided by 8 is 5. We get the same answer as before, we just found it in a different way. Our last example is to reduce 75 over 100. Again, we're going to think about what's the biggest number that goes into 75 that also goes into 100. 25 is that greatest number that divides into both 75 and 100. Therefore, 25 is the greatest common factor. 75 divided by 25 is 3. 100 divided by 25 is 4. So 75 over 100 reduces to 3 over 4. In this lesson, we looked at reducing fractions using two related methods. The first was to factor the numerator and the denominator into the product of its primes. The second was to find the greatest factor in dividing that number into both the numerator and the denominator. Neither method is more correct than the other. It all depends on which method makes the most sense to you. Thanks for watching this lesson on reducing fractions. This is an important concept that you will revisit in many of your mathematics classes. We looked at two methods. Practice both until you are comfortable. The more fractions you reduce, the easier the skill will become. We look forward to having you join us in another mini lesson.